Performing 6 trials where the probability of success, that's what P is 0.4. Calculate the probability of 2 successes. So I'm going to grab my TI 83 here. If you got an 84, I think it's a little more functional. I'll share that screen also. That's not working, so I'll restart that. Oh, where is it? All right, so we're going to do a new share. I'm going to share this virtual TI-83. Okay, so we're doing everything in, I think it's second distribution. There it is. So we want binomial PDF.
Gotcha.
Okay, and we want binomial PDF because we're only doing it at one point. Now yours might have like fields to enter. Mine doesn't, so I need to see what to put in those fields. What does yours say? What fields do you have there?
Trials, P, and X value.
Okay, so the trials is 6, P is 0.4, and the X value is 2. So when you enter those in to your calculator and hit paste, you should see something similar to this on your home screen.
Yeah.
And you should get that number as well.
Mine said there was an error.
Okay. Maybe just check the numbers you entered.
So it's binomial PDF, correct?
PDF, yep. 6 trials. 6 is the first number. Then the P.
Okay, so 6 trials, P is 0.4 and X value is 0.2.
X value is exactly 2. Not 0.2.
Oh, okay.
2, yeah, 2 successes. And do you want me to enter these in as we go?
Yes, please. Oh, okay. Let me look at the problem.
Yeah, now are you able to pull up the assignment also at the same time?
Yeah.
Okay.
So actually I could put it in. I just realized that.
The reason I ask is because I have to go back and forth here, or I just snip them in. And
yeah, I can just enter.
But the first, but two is exactly like the first one. So,
so then what's the point of the Q?
It's not needed, but P plus Q add up to 1.
Oh, gotcha. Okay.
But it's not needed. It's irrelevant.
Gotcha.
Okay, so let me switch back to the workspace and let you try number 2, and it's basically the same as that. So I'll make some notes here, like this is binomial PDF 6, 0.4, 2. And for number 2, because it's X equals 0, it's still binomial PDF 3 trials this time.
So if it's like on 3, because like I got 2. On 3, would it use CDF because it's like the greater than or less than symbol?
On number 3 it is, yes.
Gotcha. So that's just the difference between the two?
Yes. Now we'll probably see a problem where there's a slight variation on that, which might be coming.
Okay.
I don't know. Let me keep snipping these in. I can help with this. So that this is this is binomial CDF 5, 0.2, 2.
For number 3, it was wrong, so I don't know. I put 5.2 and 2.
That's good. And make sure you use CDF.
That's what I used. Okay, let me see if I. Okay, so binomial CDF, there's 5 trials. P is 0.2, and then the X value is 2.
Yes.
I get 0.94 2 and it like O and it tells me I'm because I have to probably round the 0 to a 1.
It says 5 decimal places on this one, on number 3.
And there's the reason.
It's always something.
Be something small. Yeah, there we go.
Okay, so number 4 is a PDF, 5 is a CDF. I'm going to mute you for just 30 seconds here. All right. Were you able to do 4 and 5?
Yeah, so it's 4 N is just what I would put in, correct? Like N is my trials.
Yeah, and is the number of trials. So for number 4, it's 6. And then the third number is 3.
Gotcha.
Number 4. I'll snip these in, and that way you have them later if you want to look back at the notes.
This is not difficult at all.
No, maybe it will get more difficult. I don't know. Well, I know it changes at after 5. It becomes a different style of question. Not style, but different type of question.
Gotcha. Okay, yeah. So I'm on 6.
All right, so you're up to 6 now. So 6, let me snip that in. We can talk about it. This is just a word problem of the same type. So you have to identify N, X, or NP and X. Okay, so the probability that a randomly chosen person in the Netherlands connects to the internet immediately upon waking is 0.25. So that's your p value. So you need N and you need P. P is 0.25. And a random sample of 5 people, so that's N is 5. They want to know the probability of that X equals 2. So because it's an equal, this is a binomial PDF of 5, comma 0.25, comma 2.
Gotcha. That's simple enough as well.
All right, 7 is actually a good one for us to do together because it is a variation on this. So 7 here, let me snip this in.
Okay, wait.
Yeah, let me know when you're ready for us to go through 7.
It says that I did that one right. So trials 5, P is 0.25, X value 2. Oh, I probably should have to round the 6 probably to a 7. That's probably why. Okay, yeah, all good.
Okay, so number 7 here. In a large job training, half the participants are female and half are male, and a random sample of 4 participants. Okay, so that's N equals 4, at least 1 male. So that's your X. Now P is not given, but they tell you that half are male and half are female. So P is 0.5. Okay, so your calculator does not do this, what's here. And this is the only kind of explanation we need. So I'm going to write 0, 1, 2, 3, 4, and 5. I'm sorry, I guess 4 is the end point. So greater than 1 includes these, but you don't want those. You want the other side. So there's 2 options here. You can either do a binomial PDF at 0, so 4.50, or you can do a CDF and they give you the same value at 0. Because it wants greater than 1, you need to get this number, either one, and then subtract it from 1.
Gotcha. So it doesn't matter which one I choose. I just have to subtract.
Yes, because you're getting this one here and you want the other one, so you subtract it from unity or whole 1.
Simple. Okay, that's good. Gotcha. Gotcha.
Okay. Let me know when you get that and we'll go to number 8.
Yeah, got it.
Okay, so 8 is another one of these word problems. You have to identify N and P. So there are 5 airbags and P is 0.3. So for part A, since you want X equals 2, it's a binom PDF of 5, 0.3, 2. And then part B, this is more involved than the previous one. So I'd like to just spend a little time talking about that.
Okay. Gotcha.
Were you able to get this answer for part A?
Yeah.
Okay, so for part B, they want X greater than or equal to 2. That's this right here. Okay, and the calculator can do 0 and 1 together. It can do this with binom CDF of 5, 0.3, 1. CDF gives you the left one, so 0 and 1. But since you want the 2, 3, 4, and 5, you have to subtract that from 1.
Okay.
So when you want the right ones, you generally go figure out what left you need and then subtract from 1 almost always.
Gotcha. For some reason it says it's wrong, but it could be just a rounding thing.
Okay, let me give you my answer here. Let me get a tool to do this. All right, so 1 minus, what is it? P binom. So 1 probability equals 0.3, size equals 5. So I got 0.4718.
Okay. I must have done something wrong. Okay.
Did you use CDF?
I think I used PDF, that's why.
Okay, yeah, so PDF or PDF is only used when you want exactly 1 point. CDF is used when you want more than 1 point. Since we wanted 0 and 1, that's why we use CDF there.
Gotcha. Okay, so 0.4717.
Yeah, 1.8. I mean, it probably will accept the small variation there.
Gotcha. There we go. Okay.
Okay, can we move on to 9?
Yes.
All right, so 9 here. I think I got this ready. Yeah, so this one, N, there's 10 teenagers, so N equals 10. P is 0.74. Okay, and they want the probability that X is greater than or equal to 8. So you see me do this a bunch of time now, and so I write all the numbers. You won't need to do this when you're ready for the exam, because you'll know this really well. But we want this group right here. Binom CDF though will give us this group.
Okay.
So since we want binom CDF, we're going to do that for size 10, P of 0.74 and 7 because of that number there, because we want everything 7 and lower.
Okay, so it's always just one behind whatever they're asking for. Like,
Well, the truth though is that's because it's a greater than or equal to. If it's a greater than 8, it's something different.
Gotcha. And I still subtract from 1, correct?
Yes, that's the last little thing there.
Okay. Gotcha. There we go. So just 10.
Yeah, let me know if there was any errors on that or
That was
issues.
good. All good to go.
Okay, let's look at number 10. I think this one I might have to read. There's usually one that's kind of like where it doesn't want you to use P, it wants you to use Q. Okay, there's a lot of things that aren't important. Assuming that onboard computer is 97% reliable, failure is 0.03. Was it probably that at least 2 of the 3 computers will malfunction? So that's the probability that X is greater than or equal to 2. That's 2 of the 3. Okay, so an N is 3 because that's how many there are. P though is 0.03 because that's the malfunction
Gotcha.
probability. And again, so it's 0, 1, 2, and 3. And this is what you want. Binomial CDF gives you this.
Okay.
So if there's anything you're taking away from tonight, hopefully it's this binomial CDF stuff, and it's 1, it's the value 1 there, and then you do a 1 minus on it.
Yeah, gotcha. Done with that one.
All right, so we can move on to number 11.
Yes.
Do you want to give this one a try on your own?
Yes, I can.
Oh, this isn't fair. We haven't done one like this. Sorry.
Yeah, you're good.
Okay, so you want 79 like through 89.
Mhm.
Okay. So if you do a binomial CDF of 89, and actually that's the wrong number there. Sorry, let me do, it's 100.8 comma 89. That'll give you everything left of 89. Do you agree with that?
Mhm.
But what we want to subtract out the stuff left of 79, but that really it's the 78s that we want to subtract out.
Okay.
So you subtract out the binomial CDF of 78. So 89 includes 89, 78 includes 78. So that gives you 79 up to 89.
Okay.
With
So
this
then I
calculation.
subtract the two from each other.
Yes. And if you can do them all at once, or you can get one answer, get another answer and subtract. Either will work.
Okay. Gotcha. That's not difficult either. Perfect. Gotcha. All right. I'm done with that. That wasn't difficult at all. I just swear the way my professor decides to teach it is just 100 million different ways
Yeah.
than this.
Well, you're in some ways you're paying for this kind of expedited service with me. I mean, this is, we're cutting through all the stuff you don't need to know, and here's how you do it. And you did a bunch of these on your own, so you know how to do it for the exam. So
Yeah.
this is ideal. I mean, in my mind.
Yeah, no, trust me, it's a lot better than the way he does it. I don't even understand that. So
Yeah. Well, we have some time left. If you would like, what can we do next? Or it's totally up to you. It's your time.
I wanted to look at one of my past assignments, section 8.43.6.
Is that a WebAssign section, or is it
Yeah.
something? Okay, could you put that into the chat real quick so I can go look for it?
If you just go to my 10 assignments, you can see the. Okay, so 8.
so sorry, 8.4 to 8.6. Okay. That's not something we have looked at together, is it? It's new,
No.
new stuff. Okay.
It's
All right. So let me go to your assignments and go back to past assignments. And let's see. Okay, they're all grouped together. I see. Okay. Yeah, these are something. So I'm guessing the ones you want to go through are like the probability ones with like word problems ish.
Yeah. It kind of had to do like last week when I was studying for that quiz. It was just kind of like whatever ones are like conditional probability or individual events.
Do you have, is there an example of one that you want us to look at that might be easier?
I'm trying to think because I like my confusion is like which ones are conditional probability and individual events.
Okay. You want conditional probability events.
Yeah, or individual events, whichever one, unless those are the same. I don't know.
Okay, let's start with just a basic well, these aren't that basic. Yeah, well, let's start with this and then we'll move to some word problems. Okay, so this one you did completely correct. The probability of A given B is equal to the probability of A intersect B over the probability of B. And what you need to remember is that these letters always match, like the second letter matches that letter.
Okay.
Okay, and the and always goes on the top. Okay, so like this is important. Like to know this formula. So and just as an aside here, whenever you get like two numbers on an exam, like you're either multiplying them or dividing them. Like there's really only two options because of that.
I assumed here I multiplied them, but I don't know like
Well,
why.
you're solving for this thing in the top. So you're multiplying, like let's use letters here. Let's use and I'm sorry, that's not the right one. Let's just well, you can do this. Probability of B, if you multiply both sides by the probability of B, you get probability of B times probability of A given B equals probability of A and B. Okay, and all I did was just clear out that right there. So
Right.
you're given these two numbers. This is 0.5. This is 0.3. So and that's how you get the number.
Okay. And is that conditional probability?
Yes, the one on the left here is conditional.
Perfect. Gotcha. Let's see.
Okay, so that's like the basic like start of this. So now let's do a word problem,
Okay.
or actually we'll do a table problem next because this kind of leads into that nicely. Although I mean these aren't that difficult, but these are what you might see. So let me not include the answer. Okay, so this is called a contingency table or table of information. From it, sometimes you're given the total, sometimes you're not. So if you're not given the total, you want to do the total. So this is what they want down here. Okay, and you start with the given. This is where you go first. Okay, given that she is successful. So which row or column does that correspond to? Given that she is successful, it corresponds to this row. So this is all you care about.
Gotcha.
Okay. It's like, given that you're a college student at ASU, like you only care about that place, that world. How many authors are established in this row?
30.
30. And how many are total in this row? 40. 10 plus 30 is the 40.
Okay, gotcha.
Okay. So now let me give you one here. What's the probability that you are unsuccessful given that you're a new author? So this given is where you start first.
So it's just 10 out of 20.
Yes.
Okay, that's easy.
Okay. So when the numbers in the table, like that's you want those problems there.
Okay.
All right. Let's look at number 10. Let me practice another here to get the answer so that we've got the right
Gotcha.
number. And then I'll pull up the correct one here. Okay. So let's look at this problem here. Number 10. Actually, I'm gonna make this a little smaller so we can snip this in. There it is. That's reasonable. Okay, so suppose that it snows in Greenland an average of once every 26 days. Okay, I'm not sure why that's important. Glaciers have a 28% chance of growing. When it does, okay. So so snow doesn't snow, no snow. Sometimes it's good to draw these. So it snows once every 26 days and no, so 25 out of 26 days. Do you follow that?
Mm-hmm.
Okay, and these trees are important usually. Glaciers have a 28% chance of growing when it does. So when you get snow, growing glaciers is 0.28, but not is 0.72 because these have to add up to 1. When it does not, snow, glaciers only have a 3% chance of growing. So growing 0.03. So not, what's the number that goes here? These two have to add up to 1. Should be like 0.97.
Yep.
Okay. What is the probability that it is snowing in Greenland when glaciers are growing? So which path gets you to growing? There's 2 paths. Hopefully you see that. To get to growing, you either come down this way or you come down this way. Do you follow that?
Mm-hmm.
So this one right here, the way you get there, it's 1/26 times 0.28.
Okay,
This one over here on the right is 25/26 times 0.03.
gotcha.
So let me know when you get those 2 numbers.
Is the first one 0.0107?
Let's just go with 0.0107. And then what's the other one?
.023.
Okay, so now let's look at the question one more time here. It says, what is the probability that is snowing in Greenland when glaciers are growing? So which path is the snow path? It's the one on the left, right?
Mhm.
So the snow path is, let me go back to the right. I'll switch colors here. So the snow path it's over the snow plus no snow path. So
Gotcha.
in short, it's the 0.0107 over 0.0107 plus 0.023.
And that should be 2.9. Actually, I rounded that wrong.
Sure. The numbers aren't really important. What's important is like you understand that there's two paths that get you there. That those are go on the bottom, and then the one that you care about goes on the top.
Okay, simple.
So you should get a number close to this 1.2718 when you do that. Make sure you put the bottom in parentheses.
Okay, 1.7. Okay, nope.
I didn't hear that last part. I'm sorry.
I did not do it right because I got like 1.7 something.
Okay, yeah, you got to put the bottom in parentheses. That's what it is. Because when you divide the first one, you get 1 plus.
Yeah, I did. I put the bottom in parentheses, but let me. Okay. One of my numbers was entered wrong. Hold on. Gotcha. Okay, yeah, that's what I got.
Okay, close enough. All right. So let's move on to another question that's really similar. And the hardest thing is drawing this this diagram, this tree, these forks. Okay, let's see if we can do it here. Okay, in fall 2014, 38% of applicants with a math SAT of 700 or more were admitted to a university, while 12% of math SAT of less than 700 were admitted. Further, 36% of all applicants had a math SAT score of 700 or more. What percentage of admitted applicants had a math SAT of 700 or more? So this one's a little bit out of where like this is the first sentence you want to focus on. And there's two forks here. There's over 700 and then not. So 0.36%, those are all the applicants. And then 0.64.
Gotcha.
Now look at those that were over 700. 30% of applicants with an SAT score or more were admitted. So this is the admit and this is the not admit. So this is 0.38 and then you just do a 1 minus that 0.62.
Gotcha.
And then over here on the right, this is the next part. While 12% of math SAT less than were admitted. So admit, that was 0.12, not is 0.88. Now let's just say you tried to start here with this because you read the first sentence and you're like, oh, it's 0.38, 0.62, I'm really good, got this down. And then you got to the next sentence that said, while 12% of math that were less than this, you would see that this was disjointed from it and maybe have to go on to the second sentence. Like hopefully your first sentence is the first fork, but it doesn't have to be.
Okay.
Okay. The other thing that kind of helps is usually, I gotta say this, very carefully, usually the thing that they're asking about has to be in the bottom row here.
Okay.
So the path to admit is down this way, and then the other path to admit is down this way. And to get those, it's 0.36 times 0.38. 0.64 times 0.12. So we need those two numbers. And those numbers are going to go on the bottom here of our
Okay. So the admit part goes on the top, correct?
well, it depends on, no, they're both admit. They're both admit. Both of these numbers are going to go down here on the bottom. In fact, you can even write that, because in the question says, it says, what percentage of the admitted applicants had a math SAT of 700 or more? So we want the path that was 700 or more. So this one on the left here is the 700 or more. And so that goes in the numerator.
Okay.
And like I said in the previous problem, you take one number, one of these numbers or the other, and it goes in the top.
I got 0.64.
Yes, and that is the answer.
Gotcha. It's not difficult. All right.
No, the tree really helps.
Yeah.
Drawing it is really hard though. If you're not, you should do a few to make sure that you got it. So let's look at 12. If you'd like, keep going on this. Assume you do. Okay, so 12. So let's try and draw the chart here. And this one's a little odd, but let's go with it. Certain year, 45.4% of all vehicles are cars, and the rest are pickups or SUVs. So let's just assume that that's the starting point. So this is vehicles. You don't need the labels, but they could be useful. There's cars, and then there's everything else, which is the light truck or the SUV.
Gotcha.
So what number goes on the left? What number goes on the right?
1 by cars and 0.2.
So we're looking at this, right? We start with vehicles, and that's where we fork. So this is again, this is the challenge. 4.454 and then 0.546, I think.
Okay. Oh, I see. Gotcha.
So then, and this is where we're going to use these numbers. It's a little bit more difficult. We actually have to read this a little bit more. It says the probability that a severe crash would prove deadly. This, it's kind of horrible, but like if you're in a car, there's either deadly or not. And the probability of deadly in a car is, let's go up and get it, is 1, that's what's kind of odd. That means there's no probability of it happening when you're in your car. But in a light truck or SUV, the deadly is 0.2, the not is 0.8.
Gotcha.
So they don't have to give you all the numbers. They just have to give you one side or the other. That way you can fill it in for that. Okay, now what do we want here? What's the probability that a victim is dead, which is horrible, but that they were driving a car? So we need to get the paths that get them to the dead side. Dead. And it's not always this, but it does seem to be following this pattern. And then we care about the ones driving cars down here. So this is 0.454 times 1, and this is 0.546 times 0.2. And the one that we want is the one on the left. So it ends up being 0.454 times 1 over 0.454 times 1 plus 0.546 times 0.2.
Gotcha. And then that's my answer, I assume.
Yes.
Gotcha. Okay. Yeah, that one's not hard. It's just, I guess, paying attention to that detail, kind of.
Yeah. Yes. I would recommend like doing these with some break time, and then you'll have the notes and you can compare to it if you want. All right, we got one more of these to look at. Some of these are sort of negative. It's like didn't get in
Yeah, really
college,
dying.
died by a impact. It's about fitness. All right. In fact, so you gotta stop. You don't have to read all this stuff. You gotta get to where those actual numbers here. A study suggested that 47% of athletes fit enough to play on the team would fail the soccer test, although no unfit athlete could possibly pass the test, are fit enough to play soccer. Assuming these estimates are correct, was the probability that Mona was justifiably dropped? Okay. 47% of athletes fit enough to play on the team would fail. Fit enough to play on the team would fail the soccer test. So I think we start out with a test. And this one's, this one's a little bit tougher. So there's are fit enough to play. So 35% of the athletes who take the test. No, this is test. Are fit enough to play soccer. No. Okay, so let's I guess start with the soccer. Fit enough. So the fit and then not fit. So there's 35% of the athletes who take the test are fit enough to play soccer. So 65% are not. Then we go back to this number, 47% of athletes who play on the team, fit enough to play on the team, would fail and then pass. So 0.47 fail, 0.53 pass. Okay, and then this is also key, is that like the branches are the same each time, fail and pass. And so like what's going on over here? Well, it says it's kind of this weird thing. It says no unfit athlete, so that's right here, not fit, could pass the test. So if you're not fit, you're never going to pass the test. That means 100% failure. And if this didn't make sense, it's confusing for me too. I mean, you're not going to see this on your test, but
This one is a little more confusing, but I can see where you like acquired all the numbers.
okay, good. So now that it's also intentionally vague where it says justifiably dropped. So that means the person failed and the other fail, but the like justifiably dropped means that like she actually couldn't pass the test. So it's this one on the left, this 0.35 times 0.47, that's your numerator, over the other path here, which is 0.65 times 1. And that should get you back to this number here.
Okay.
Okay, well, this is probably about as good a place as any to stop. Hopefully these examples are a little more clear now. I will send you the notes here shortly. And appreciate you scheduling, and let me know when I can help again.
Gotcha. Thank you very much.
You're welcome. See you next time.